Nice. Okay, are we on?
Yes.
Are we live?
Well,
Here we go.
Tonight, we have one of our own, Alan Witzgall, who will be giving us the scoop on two very important solar eclipses that are going to occur this year and next year in the United States. So please, everyone, welcome Alan.
Thank you. Thanks for the introduction. Appreciate it. Oh, yeah, it's great. Good evening, everybody. Welcome to the observatory here. NJAA welcomes you, so do I. And I'm going to be talking, as you probably already know, about a total solar eclipse. But actually, we're talking about two. First, an annular, and then a total. We're going to define what that is and what you can see from here. Now, eclipses occur all around the world, and we are lucky here in North America, in the United States, because in the span of 7 years, 2017 and then 2024, we have two total eclipses of the sun. The odds of that happening at any given place on Earth are maybe about 50-50 to winning the New Jersey State Lottery twice in a row. That's the kind of odds. So you were in the right place at the right time, which I think is fantastic. Okay, if anybody has the numbers, by the way, let me know. So let's get right down to it over here. As I've called it, the Great National Total Solar Eclipse, the dance of the sun and the moon. So let's see. There we go. It's an awesome spectacle. This is what the total eclipse seen from Hawaii at that time looked like back on July 10th, 1991. It's an amazing spectacle. What you're seeing over here is the dark disk of the moon silhouetted against the sun and the corona, its outer atmosphere, framing the whole picture. Because of an astonishing coincidence, our sun's diameter is 865,400 miles. The moon's diameter, 2160. Sun's distance, 93 million miles. The moon's hop, skip, and a jump at 239,000 miles, or the sun's 400 times bigger than the moon, but the moon is 400 times closer. So therefore, we can have what we call total eclipses. In other words, the disk of the sun is completely covered for a certain period of time. Nowhere else in the solar system is this geometry repeated. If you observe the planet Jupiter, it's got four large, out of I think it's 100 now, it's about 140 some odd moons, most of them little asteroids, but the four major ones cast their shadows onto Jupiter, and you see them. You see this little dark dot preceded usually by the moon doing this work. Thing is, if you stood in that cloud deck and looked up, you'd be seeing what's called an annular eclipse. We'll talk about that later, but it's not completely covered. Okay, a little physics. You knew you were going to have some science in this thing, right? Okay, our sun is a typical star of its kind, the G25, meaning it's a relatively dwarf yellow color star. It's about not quite halfway through its lifetime, lucky us. So what you basically see here would be, and I'll get this chair out of the way, unless we can get the pointer up. Yeah, there we are. Okay. In the core of the star, of course, is where the fusion reaction occurs, taking hydrogen, fusing it to helium, and you lose a tiny bit of mass that's in the form of energy, and for that matter, that mass, every second, 4 million tons of hydrogen is converted directly to energy. That's what powers life here on Earth, which allows us to see the daylight, and you have life all the way to the bottom of the oceans, all the way to the top of the atmosphere, and everywhere in between. All life really owes itself on this reaction in the core. Outside of that is an area called the radiative zone, which, as the name implies, all this energy has to go out, and it goes out in a more straight line. But as it's doing that, it's losing its temperature, and the core is 15 million degrees in Fahrenheit, that is. It literally cools down once it gets past this thickness of matter. And in the convective zone, as it's called, the temperature is lower, and it starts moving all the super hot gases, more plasma, electrons stripped away, than anything else. Once it gets out to the edge, then you see it. It takes, we guess, about between, depending who you read, 10,000 to 50,000 or more years for that energy to leave the core of the sun to make it to the surface. And then 8 1/3 minutes later, bang, we see it here. The light can't wait to get out of there. However, there's a lot of other stuff we can see here. Invisible light with a special filter. You can see occasionally, every 11 years, we have a group of magnetic storms called a sunspot. And right now, it's relatively active. We're coming toward a solar maximum, I believe, next year, a year after next, I'm sorry. Above that is a layer called the chromosphere, which you can only see either with a very special filter or just a little bit of a hint of it when you look at a total eclipse of the sun. It's about 4,000 degrees colder than the nominal temperature of 10,000 here at the normal visible surface. Above that, with the chromosphere, you have prominences, which quite frankly are gigantic magnetic fields holding all that hydrogen together. Really wild stuff, because the magnetic fields are changing, so the appearance changes, sometimes minute to minute. And beyond that, and only visible during a total eclipse of the sun in nature, we can get a little bit of a hint of it with our satellites and with observatories with special equipment. The corona, the outer atmosphere, this is funny. The corona is 1.5 million degrees. Oh, great. Thank you. Okay. All right. Everyone's going to have to behave now. I'm armed. Okay. Then the coronal streamers basically is the outer atmosphere. It's heated to about 1.5 million degrees, but its density is about what I find inside a fluorescent lamp. So this is a wild group of coincidences, and it's only 8.33 minutes away at light speed. Okay. Now, this is how they work. The moon's orbit's tilted 5 degrees to that of the Earth's path around the sun, and it crosses in front of the sun only when the shadow lines up with the Earth. We average around 2 solar eclipses per year. And these eclipse seasons happen only during new moon phase. Solar eclipses repeat every 18 years, 10 and 2/3 days, and are said to be members of a given Saros, or family of eclipses. Interestingly enough, this number was discovered by observers back in ancient Greece, confirmed by the Romans, and we reconfirmed it when the Enlightenment started. All during this time, these guys didn't have telescopes, but they knew how to observe, and they knew how to record time. That's how we know that. They had come up with this. Well, the only thing we've done over here is made the 2/3 days maybe a little bit shorter. That's amazing. So here are the types of eclipses. The ones that I personally am most interested in, and you probably are as well, what we call total eclipses, where the moon is close enough to the Earth to block out the sun and cast the shadow upon the Earth, and we stand in the path. And it used to be in the old days that civilizations would see a total eclipse. They had no idea it was coming because, quite frankly, they didn't have the math at the time to be able to do the predictions. So therefore, they would see the sun start to go. Some people would yell and rant and rave because they thought a demon was eating the sun. And apparently all that running around and banging pans and firing off fireworks, depending on what civilization we're talking about over here, it worked. It moved it out of the way. I'll tell you, that dragon wouldn't come back for 18 years and such. At least that's what we think. This is how the path looks against the Earth. The shadow just walks across the planet. Okay. 2 others, of course, annular and central. A normal Saros, a family of eclipses, starts with a tiny little notch for maybe 20 or so minutes, maybe less, in Antarctica, and from every 18 years, etc., walks up the disk. It's getting bigger and bigger as the moon is getting closer and closer as this develops. Then finally, there's a moment for a second or two called a central eclipse, where for a moment it blots out the sun and then moves on its way. We had back the late 90s where I went to Saluda, Virginia, expecting to see the eclipse, and of course all I did get was rain in the face because it was raining. However, the lighting, you know how a gray day is during a rainstorm? Imagine for a moment the light goes all the way down almost to night and then back up again. 2 seconds. Boom, boom. And I said, oh, man, I couldn't even see the darn thing. You'll see a picture of what that looks like later in the talk. But the guy that took that picture was risking his vision because he had to put a filter on one side of the viewfinder. It was a film camera at that time. and waited and finally took the cover off. It looked centered and took the shot, and he actually got the picture. I was really surprised. You'll see it in a little bit. But sometimes you also have annular, where it's getting closer to the Earth each pass that the moon goes around over those years. And there's a point where there's still a big ring of fire around it. There's a whole group of them called annular or ring eclipse. And I'm going to emphasize this all through this because I think everybody here is aware that you shouldn't be staring at the sun. Okay, I pretty much we get the idea. We'll talk about a little about that later. But with this type of eclipse, which is coming up in October 14th, okay, it's not going to come here. We'll see a partial eclipse. So it's dangerous to look at. Even the annular phase, if you go on the path, well, I'll show the map later. But even if you look at it when the moon is fully centered, you still have this nice ring of sunlight, and it will blind just as much as looking at it straight on. Something to be aware of. Okay, and like I said, we have a partial coming up from here on October 14th, roughly, I think it's about 1:20 in the afternoon, thereabouts. This is what you would see with a filter. Actually, well, much more of the sun. It's only going to cover roughly about 35% from here. And basically what's happening with a partial, you're standing over here. The action's in here, but you're out here. Now, why you do that, I have no idea. But this is dangerous to look at without a filter. Okay. The corona, the outer atmosphere, is affected by the activity of our star. During solar maxima, and we're coming up on that in 2025, the corona is contorted and expands out from the far side. At minima, it huddles close to the sun. Like, I believe this is the 1971. This was in 1991. In either case, this is safe to look at without a filter. The brightness of this corona, this outer atmosphere, is about the same as the full moon. Okay. And just before totality begins, the last rays of the sun shine through valleys on the edge of the moon just before totality, creating this diamond ring effect. Magnificent to see and astonishing to realize you're looking up, and that is what's left of the sun shining through those valleys on the edge of the moon. Okay. And I mentioned, about this central eclipses. This is that dangerous, risky as all heck, photograph. This is where a filter was cutting the image in half, and this was the natural diamond ring effect and Bailey's beads, as they're called. Again, all these wonderful valleys on the edge lining it through. And look at that. He caught a prominence, one of those big tongues of nuclear fire off the edge. That's amazing. So he got Danny DeCicco, by the way, was the guy. He's an editor. I think he's a senior editor now of Sky and Telescope magazine. He wrote about this, and I said, you lucky dog, you saw it. Okay. If the umbra doesn't reach the Earth's surface, as I mentioned before, a ring of sun can be seen, just like this picture here. But this is just as dangerous as looking at the full moon, a full sun rather, without a filter. I want to emphasize that. I'm pushing safety. We have a bunch of young children in here, and we have some young children disguised as adults here. I don't want anyone getting damaged. We're going to talk about that later. And if I scare you, good, then I'm doing my job. Okay, let's continue on here. Okay, totality came to Hawaii, 1991, Mauna Kea, on the Big Island, and there is the totally eclipsed sun. I got lucky with this picture, folks. This was a Celestron 5 at f11, 200 speed film when they still had slide film, Ektachrome, 1,000th of a second. That's the last gasp of the sun, and look at that beautiful prominence. I got lucky. And the color, by the way, is from the hydrogen gas. It glows especially in the red, but there are other colors too, but we got lucky with this. So did I. We almost got rained out. Whoop. I'm going to go back. Okay. Okay. There's totality in Mexico City. And you can see this is a great picture because every couple minutes, I think it's every 5 minutes, this has to be timed properly. But there it is. They pull the filter off and then put it back on for it to go out over a beautiful church over here. Okay. Companions in the sky. This is from Aruba. Some of the places that eclipses occur are really rough and rugged. Some of them are terrific vacation places. That was Aruba. Mercury and Jupiter flanking the overexposed 1998 eclipse. I got this one 1 second, a little overexposed, at f3.5 for those of the photographers here. A 200 millimeter telephoto. I was worried about the shake that you might get when I hit the shutter release. So I just basically put it on the tripod and prayed a lot with a short focal length lens. Okay, part 2. Regulus in the August 21st, 2017, of one of two that in this period of 7 years occurs in North America and particularly in the United States. August 21st, 2017, again 200 speed, 4-second exposure. This time I used my trusty 700 millimeter refractor, which has been with me since 1968. And there's a reason for me mentioning that. That was a Sears refractor, the old Sears Discoverer. And the only thing original about it, by the time this happened, was it was just the objective lens, but it was such a great piece of optic. Gave it a whole new tube, new focuser, new everything. Put the camera on, and this is what she gave me back. Bessie, as she's called. And this is at f11. And let's see. And there you have the star Regulus. The brightest star, the heart of Leo the Lion, as they say. And I had a problem with, how many photographers are in this room right now? People that have worked with the camera? Anybody? Okay, so you'll get the joke on this one over here. You know about depth of field? Okay, this is here. This is 93 million miles away. This is 26 light years away. You try getting that all focused together. Yeah, so, ba-dum-bum. Anyway, but I got lucky. I got very lucky with this. I was very surprised. Okay, now, companions in the sky. Comet Pons-Brooks is coming back in after, I think, a 75-year orbit. May be visible during totality coming up. There's Mercury, there's the eclipse sun, Venus over here, going further to the southwest. There's Jupiter. Jupiter is the guide. If the comet's going to be seen, it'll probably be in a pair of binoculars, but we'll keep our fingers crossed. And the last time that happened was in 2020, November. Before that was 1948. Okay, there's a close-up. A wonder in the darkness, if I can borrow the line from Star Trek. There it is. And this is local time, actually. Yeah, that's right. That's local time. Well, this will be occurring actually in Central Time. Okay. Timing, again, is everything. All total and annular eclipses move fast. That moon shadow kicks across the Earth at about 1,500 miles per hour. And the width of the shadow is usually just about 120 miles. So observers must station themselves on the path of totality, close, if you can, close to the center line. Most of the time, the duration of totality is, on average, around 2 minutes. We're lucky. Because of the geometry, Earth is turning this way, the shadow's coming with it, so it's going to extend the time on the ground. So we're very lucky. At its best, and to do that, you got to go to Mexico. I don't recommend it, unfortunately. But it's a shame because it makes landfall in Mexico. It'll be 38 seconds long. That is unbelievably long. Where I'm looking at myself, I would love to go to Texas. I'll mention that in a bit. Texas Springs or Waco, where it's going to be 4 and 15 to 4 and 18 seconds, minutes and seconds. And it's crazy. It's still going to be moving along, still moving fast. But again, the Earth's compensating for its movement. So by the time it goes off the coast of Canada, it'll still be about 3 minutes and such. So it's tracing along. This is my kind of eclipse. Okay, and now the upcoming solar eclipses. Okay, this is, of course, map of the United States. This is what's coming up in October 14th and April 8th. Look how close it comes to the New York area. But you can, if you go to Buffalo, shuffle off there, you'll still get about 3.5 minutes. That's really cool. Near it is Niagara Falls, and a friend of mine's going there because her husband said, I've never been to Niagara Falls. Where's the path going? I said, well, that's where it is. That's where we're going. I'd rather be down here. Down here is the old 4 minutes and 20 some odd seconds, but you can see that path going through here. And this is actually a poster through the eyes of NASA. Okay, and this is the more or less official way of looking at it from the 1,000-year canon of solar eclipses. You can find this all on the web. And the May 1994 annular eclipse at Stellafane, a little bit north of Springfield, Vermont. And this was with a filter. There's the ND5 over there, 200 speed, Bessie, 2.4 inch, a 200th of a second. Notice it's not quite centered. We didn't realize at the time, if we had gone 10 miles further up, I could have got a perfectly centered sun. But again, this is through a solar filter. Okay, and then the great national eclipses, they're calling them. The formal announcement, this is that path of that annular eclipse. Look how far down it goes. All the way across South Am. That's amazing. And we're going to close in on there in a minute. Okay. And across the country and beyond. There's the path of annular eclipse. We're up here. So this is going to be just about 30%, a little less than 30% covered, which means you need a solar filter. Okay. Let's go in. And now, the great national total solar eclipse. Okay. And here's the official map. Greatest eclipse is right in here in Mexico. And then, again, because it's moving with the Earth, it's actually extending it. And you can see how close to Europe it gets. And this is the path going across the United States. And there are some places, as a matter of fact, one place I would like to get to is right here in Illinois, where I observed in 2017, saw the total eclipse that went over that. Carbondale had a stadium, had 14,000 people. They had about 100 or 200, I think it was about 100 photographers of all kinds, from amateurs all the way up to professionals, with all sorts of equipment. They were on the 50-yard line. But somebody didn't throw the ball. The problem was it started to rain. Finally, the clouds moved away, and they got 20 seconds out of 3 minutes and 40, I believe. And so they kept on getting the pictures, but they got them. It was kind of wet. There were a lot of very angry people. You don't want 14,000 people yelling at you, imprisoning you in the stadium. But that's what happened. But nearby, meanwhile, in Marion, Illinois, about 12, not quite 12 miles away, we were dead on the center line, and we did get to see it. There was a little bit of cloud and haze, and it faded away. There's a phenomenon called eclipse weather, where you have the clouds are there, and they're starting to get in the way, and then the air cools because the sunlight coming in is less and less. Sometimes it clears out completely. We got lucky. Oh boy, do we get lucky. At that time, I should have got a lottery ticket in Illinois. Probably would have won. But this is the path going across the United States and up into Canada. Okay, and where to go. And you can find this chart on the greatamericaneclipse.com. And I brought it here so you can see the population. Montreal is probably the most populous place to go to. And the lowest on the bottom down here is in Little Rock, Arkansas. But you can see all the way on the path up here. It really cuts through. 1972, I was right here in Nova Scotia. You know that Carly Simons, You're So Vain. You flew your baby up to Nova Scotia to see the total eclipse of the sun. Carly was over here and I was over here. It wouldn't have worked. I was 18. She was, I think, about not quite 30. But hey, you know, it doesn't matter. The whole point here is that there are a lot of cities on the center or close to the center line. Okay, so close up on Texas. Look at how lucky this area here. I mean, first you got this annular coming through, and then the total crossing the T, if you will. Okay, moving the path. There's Marion, right in here. Yeah. Okay. Up through here, Chicago's off of the side. Akron, Ohio, Cleveland. There's Niagara Falls, and there's Buffalo, and my friend's going to be right up there. So hopefully we'll all see it. Be nice. And then further up on the path, north of Rochester, going up and all over Maine. So this is the whole this is one of the saddest things I have in this talk, because there's cloud cover. Okay, so about 50% right in here, right where I'd like to be going at that time. Look down here in Fort Worth and Dallas. Fort Worth is in the path. Dallas as well. In Mexico and sections up here where it's outside the path. This is a great place to go. Durango, a few others. The problem is, of course, we have a problem with the border. You probably heard about that. And I'm really concerned about that because I'd love to be down here, Sulphur Springs or Waco, because it's right on the center line. Unfortunately, I think it's not safe enough. We'll see what happens. See, human events get in the way of all these things. Okay, so practice safe sun. The best solar filters for your telescopes or your binoculars cover the full aperture of the scope and keep the heat and light of the sun out of the scope. Whether they're made of glass or coated polymer, these all are safe to view or photograph. Now, I'll have a caveat on that. If you get solar glasses, oh, this is very convenient. It's right here. I love it. Okay. When you open them up, see, you might go on the web, you may find your own, and we have them over here too, apparently. It'll say on here, these requirements for ISO, International Standards Organization, 12312-2-205. That's been revised for the 2015. These are perfectly safe to look through. If it's got that number on it, somewhere on it, you're okay. I've seen no name, no sanity, in my eyes, filters already that don't have that on there. Now, I don't work in an optical shop anymore with access, at the moment, with an access to an infrared spectrometer, but I would lay money on it that they peak somewhere in the infrared, and I would not touch them. And I'll show you a reason why in a few moments. Okay, so these are safe filters. The Mylar, like these, or polymer filters, glass telescope filter, Bada in a homemade holder to put in front of your eyes or in front of your telescope or camera. Mylar Eclipse viewer. Roger Tuthill's been dead now for, God, got to be at least 15 years. But he gave the world an incredible piece of work. He found a piece of Mylar, and they used it to cover tents in 1973 in Mauritania for another long eclipse. And then he realized he could, with 2 layers of this, he could look straight at the sun. So he followed a hunch when he got home. Had a friend in an optical shop in Plainfield, I think it was New Jersey, South Plainfield, and he put in what's called a spectrophotometer, and you see the visible light just about penetrating the infrared down to 0, to the limit. And he said, this is going to work, and he patented it. And all the other filters that followed came from his work. Oh yes, and the good old standby here, number 14 welder's glass. That does still work.
Make sure it's number 14.
Yeah, it's got to be at least 14. Preferably, maybe 15 if you can still find 15, but yeah. And glass, not plastic, which is the other part of that part here. Now, here we are, danger. Do not use sunglasses. You can take 50 of them and stack them together, which makes it really weird, but it won't stop the infrared. Photographic neutral density filters, they're made out of gelatin and carbon loves to filter out white light, but the infrared goes through like there's nothing there. Smoke glass, oh boy. I keep wondering, part of my vision kind of fell apart because I read about this in older astronomy books. So I'd smoke a glass, basically take a candle and get all the smoke on there. And yeah, it does filter it out, and you're probably French frying your retina if you're not careful. Polarizing filters do not work, period. Okay. Compact discs, yes, you'll punch the light through, but the infrared, again, this is a compact disc, and DVRs rather, will let the IR straight through because those coatings are transparent to the infrared. Floppy disk media, I don't even know where you can get a floppy disk anymore, but forget it. And black color film, that's a dye. It's not going to work. And here's a very lucky guy that did not look quite at the sun. This is a very unlucky person. I went crazy on the web trying to find a broken one. And there it is, because you can see the sun hit it and cracked it right across. So observers, don't let this happen to you. Okay, there. This is what I'm talking about. Using improper filters can result in permanent damage to the retina of the eye. I just recently, in the last year and a half, had cataract operations in both eyes. So I know where I speak from when it comes to the infrared, because I worked in an optical shop too. Laser optics, not this stuff. And there is a young woman back in 2017, I'll never forget it. Young kid, really pretty. And now she has, because she wanted to see the sun, so she looks up and looks up and looks up. And now she forever will have this nice crescent, dark black crescent in her vision. And I'm wondering if now, years later, a couple years later, she's starting to say, maybe it wasn't a very good idea. This is what it would look like. It's kind of like macular degeneration. but worse. We have a possibility of curing macular degeneration. I've been reading about it lately. We can't repair the retina. Use only those that are certified, as I mentioned, by ISL. This is what it would look like. Imagine having this in front of you. You are technically, legally blind. You can't drive, you can't do fine work, and that's unfortunately forever. Okay, so here, how to use filter glasses. Here's Bonnie, who is going to demonstrate this close to Totality Avenue, 1 and 9 North, in front of our porch and such. This is the target. You face away from the sun. You put the glasses on, you make sure that they are on secure. You can even hold them if you want. Then you turn around to do an about face and look up, and you'll see a little yellow disc. And we don't have voice with this, but she was going, ooh, ah, and there you are. And then when you're done, you turn away from the sun and then take down the glasses. Okay, everybody got that? Okay, please. Okay. Okay, now the safest method of all, look at the partial phases, or if you can't get to the center line to see the partial phase effect, is through projection. You can take a pair of binoculars, hover over one, and let the other one through, and there's your projector onto a screen. You can watch it. Many people can do it too at one time. The pinhole method does work as well, and you got to just get everything lined up properly, but this is completely safe. Okay, and you can get creative. This is shining through the leaves of a tree. This is a colander. This is a person's fist, and look what's there. He's just holding the sun. And then a Ritz cracker, one of my favorites. And there you are, little baby crescents down there. So you see, even a baker can be an astronomer. Okay, and if you needed another reason to go, folks, Jupiter is going to be a convenient guidepost to find Comet Pons Brooks, which will be just 6 degrees west. That's the Boy Scout salute west of the planet, and about 24.5 degrees, 2 hands were spread out northeast of the sun, and it puts the comet about the same binocular field as a pair of 735 7x50s as the gas giant. And of course, I question, okay, this is going to be amazing to see, maybe to photograph. Why are you looking over here? You're supposed to be down here. Well, that's just me. Okay, so suggestions for photography, folks. Practice with your filter on the telephoto or telescope you will use for the partial eclipse seen from New Jersey coming up in October 2023. That's the annular eclipse. We're only going to see partial. So even with the annular eclipse on path, you still need to have that filter. Use the full moon to get a feel for the image size on the photo. If you're on the center line, lucky person, turn off the camera's flash, please. There are ways of taking your smartphone and turning off. It's got instructions somewhere so you can turn it off. You don't want to be in the middle of the crowd, everybody going ooh and ah, lots of camera shutters going off as the total phase occurs, and then you come in there with a supernova at 10 feet. You don't want that to happen. They will find you. Trust me. But I'm deadly serious. And adjust the focus during the partial phases till you get a good, sharp image. Set the speed, I recommend 200. And of course, the focus to infinity. And vary exposures up and down as much as you can to get a good representation of the event. The shorter the exposure, the tinier the corona will be. The longer the exposure, and you need a tripod really fairly to do this, the greater the extent of that outer atmosphere of the sun will be. Okay, and the table for various DSLR focal lengths. If you have a full frame and crop center, you don't have to sit there and write real fast and such. I have a handout. Unfortunately, I think I'm going to need a lot more handouts where I have a lot of this information in there. So if you're going to be doing serious photography, please see me after the talk. And I'm going to see if I can make more copies of this and have them send them here. So if you come back next month, we will have a bunch of this for everybody. Okay? We're all good on that? Good. I know I won't get 5 feet out that door without somebody going for it. But this gives you an idea, the short focal length with a huge full frame view, or 35 millimeter if you're still using it, how big it is. 2,000 millimeters, it's very tight, but you're closing in really, really tight on the sun itself. Image scale, give you another way of looking at it. That in blue is with a DSLR in black is the standard photography, 35 millimeter film. And you can see probably a good balance right down about here, 1000 millimeter. Of course, you get the outer corona and, of course, the innermost and any prominences that'll be there. Okay, this gives you an idea of some examples. The outside rectangle is a field of view for like a Canon or a Nikon DSLR. The inside is for the 4/3 system, Olympus and Kodak DSLRs. Good, like I said, a good happy balance, probably be about 400, 500 millimeter, because you get all the action. Okay, so here are the paths from 2001 to 2050. So if you don't mind going to in August, 2044 is the next bet. Next really good one, though, it's down here, 2045, August 12th. Right over here, it's near the maximum the eclipse can be, 6 minutes, 6 seconds. The longest you can have it on Earth, and we're past that time now, is 7 minutes and 28 seconds approximately. So here we were in Illinois in 2017. This is where I hope I will live long enough for it. And right here with cross, look at all the people that would see this twice in 7 years. That is amazing. Okay, and don't be discouraged. I mean, I'm hitting you with a lot of information all at once. I recognize that. My brain is fried too when I think about this. But if you're going to be worried about it and such, pity this poor guy. This is the very first photograph we have, not a drawing. Back on July 26th of 1851, photography was in its infancy. The speed of the plate he did this on today would register at about 5. I mean, that's you're better drawing it than trying to take the picture. And he only had just over 90 seconds, if I remember correctly, to do this. So he sat there and he literally had to guide on the sun to be able to get this. This is a tintype image. Barkowski left us a great legacy. Okay, now some sources of filters and viewers, and we have filters. Jim, Roselli, hello. Okay, Jim, we do have filters for people here available for the sun.
We have some.
You have some? Okay. And if we run out over here, we'll get more.
He's got his ears in.
Oh, I see. Okay. All right. Well, yeah. Well, these are some sources. My favorite one still is this RainbowSymphony.com. They have all sorts of stuff. They got these diffraction gratings. When you look around the world, it's like nothing you've ever seen before because you have rainbows in front of your eyes. Who needs LSD? You've already got this. But Daystar, which has some incredibly good filters and very expensive ones too. Orion Telescopes and Thousand Oaks. And I'm dedicating the talk here to this gentleman here. This is Jay Pasachoff. He passed away late last year. Between 1959 and 2019, observed and documented 74 eclipses of all kinds. Edited, revised. If you got a copy of this, I recommend you hang on to it. He's expanded the book, Peterson's Field Guide to the Stars and Planets, a standard for observers. And yes, this is a cheese grater. And it's a multiple pinhole camera. And you can see you come up to the front, you'll be able to see little crescents. And he's got this, I love that look, like, I can eclipse the sun, can you? Good man. Yeah. Okay, so coming into conclusion here, I have to thank Witzgall who did production here. If everything's straight and everything's spelled properly, it's because of her. Michelle Tolleful is a good friend of mine, and she's inspired. She was with us in 2017 to see the eclipse in Marion. And then Fred Espinac, who did a lot of these illustrations. I give him full credit. And before anybody tries ratting on me, I don't get paid to do this. I do not hold down a salary. I'm vice president of the organization here. But I do this because I love it. Since I was about 6 years old, something like that, I got hooked on astronomy and science in general. And parents in here are going to hate me for this. The reason I got involved in science was because of comic books at that time. Showcase had a group called the Metal Men, robots that were solid metal and had personalities and were very fun and did all sorts of stuff. They kept on reminding you as you went through the story. Mercury would say, I can't go near the fire. I boil at 243.3 degrees centigrade. So iron says, I can handle it. Goes in, comes out white hot. And he says, anybody want to have a fried sandwich? You know, they were incredible. It was fun. It was great, and you learned stuff. Today, everything is kill, murder, destroy, wipe out. Nuh-uh. Back then, they knew how to write comics. They knew how to do good science fiction. So when I look at that, I say to myself, my teacher friend over here, she just retired. I had a ball with this. And I'm 68 years old. So for 62 years, I've still been a kid. Because I went from a little comic book universe to a much vaster one. And finally, Fred Espenak, who did this work, Mr. Eclipse, you want to find out everything you never even thought you needed to know about eclipses. This is the guy you go to. He's got a couple books out that deal with this eclipse. They deal with other ones. He's got a canon that goes away, well, I think it's into the 51st century. All the eclipses are going to be hitting the Earth. So you can plan your vacation for 3 centuries.